Okay, let us start now. What we are doing now?
Expression for
torque in Cartesian coordinates.
Have you finished that one derivation yesterday?
Yes, sir. I think we did.
dy equals r cos theta d.
No, sir.
No, sir.
We were doing the last part.
Yes, sir. I think we left it.
Like x into fy minus. We have finished until torque is equal to x into fy minus y into fx, right? No.
No, sir.
Okay, okay. Then again we have to draw the whole thing. Have you written the notes yesterday?
Yes, sir.
So check, okay, the diagram. We assumed the y-axis here, this x-axis. X-axis, y-axis. This is a position vector. Position vector R. This point P. Here we are exerting a force. This force can resolve into two components. Okay, this explanation, this Fy, this is Fx. This is Fy, this is Fx. And this is F. Here Fy component is more. So naturally this has a rotation to this side. Check. It's not coming back. That is P. This is the point P. Now this will be R plus dr, which is dr. This displacement is dr. Okay. Then here we can write R plus this dr will give you the OP. Triangular law vector addition. OP plus OQ is equal to the OP plus PQ is equal to OQ. Now we need to mark here. Along x-axis, this much displacement take place. Along y-axis, this is a displacement. So this we have to mark as dx, this is dy. And the angle turn here is d theta. Here vector dx, vector dy. Dx squared plus dy squared will give you dr. Okay, so this is the diagram. And this is theta. Up to here we have written, right? Isn't it?
Yes, sir.
Yes, sir.
Let us consider, write down. Let us consider.
Sir, finish writing part.
Sir, we did most of it. We reached the step dx is equal to minus y d theta.
Okay. So dw is equal to f dot dr. That we have done, right?
Yes, sir.
Yes, sir.
dw is equal to, now we have to write here components of f and dr.
Yes,
F
sir.
has
Y.
I fx
Plus
plus
Fy.
j fy. And dr has two component I dx plus j dy. Yes. Then we are substituting dw is equal to f dot dr. This is dr. F dot dr. That's equal to I fx plus j fy dot I dx plus j dy. Then here dw is equal to fx dx plus fy dy. Right? Fx dx plus fy dy. Right? Now here this equation number 1. Then we know x is equal to r cos theta and y is equal to r sin theta. Dx by d theta is equal to minus r sin theta, or dx is equal to minus r sin theta d theta, and dx is equal to r sin theta y minus y d theta. Similarly, dy by d theta is equal to r cos theta. dy is equal to r cos theta d theta. Then dy is equal r cos theta is x.
d theta.
Okay, up to here we finished, I think. Is it?
Yes, sir.
Now we have to
Yes, sir.
substitute all this in this first equation. dw is equal to here fx. What is dx? Minus y d theta. Minus y d theta. You can write it, okay? Plus fy
FYD.
x d theta. X d theta dy. Then dw is equal to x into fy d theta minus y into fx d theta. dw is equal to x into fy minus y into fx into d theta. Okay, now look here, this term. So here, have you written up to there?
Yes,
This is
sir.
equation number 2. Now, equation number 3. This you take it as equation number 1. Initially, we have written, right? dw is equal to f dot dr. Okay, that you give us 1. This you give us 2. This you give us 3. Now, compare this 1 and 3. Okay, this is dw is equal to f dot dr. dw is equal to f dot dr. That means the force into displacement give you work done in linear displacement. So here, some physical quantity into angular displacement will give you work done in angular displacement. So that physical quantity which makes this angular displacement and work is done is known as torque. So this x into fy minus y into fx, we can write torque. Torque d theta. Okay. So here, right, here, tau is a moment of force. And tau is equal to x into fy minus y into fx. This is a way torque in Cartesian coordinate system we have to represent. That means if, look here, in this situation, how will you calculate x into fy? What is x into fy? See, this I am going to draw a perpendicular line. This is the x, isn't it? This distance is x, isn't it?
Yes, sir. This is y.
So force into perpendicular distance from fixed axis will give you torque along x-axis, isn't it?
Yes,
X
sir.
into fy. Force into perpendicular distance from fixed point will give you x into fy. Agreed?
Yes, sir.
Now, y into fx. See, this is y. This position is y, right? Y
Yes.
into fx. See, y into fx.
Perpendicular distance.
That means force into perpendicular distance along y-axis will give you torque along y-axis.
Yes, sir.
Now you see the difference. Which is greater here? Fy is greater, right?
Yes.
Yes, sir.
So that difference, higher minus lower, will give you a resultant torque. That means effectively this will displace towards y-axis. Okay?
Yes, sir.
That's what this formula says here. Right? So this is the torque in Cartesian coordinate system. That means along x-axis, if you want, go through x-axis, go perpendicular force acting to it. That means Fy.
Sir,
If
so
you want
the
along
Fy,
y-axis, go along y-axis, go to perpendicular distance from the fixed point. This is the perpendicular distance from fx, y. See, y into fx. This is x into fy. Okay?
okay, sir.
Is it clear?
Yes, sir.
Yes, sir.
Now right up to here. From equation 3 and 1, from equation 3 and 1, it can be shown that from equation 3 and 1, it can be shown that torque is the physical quantity. Torque is a physical quantity which when multiplied by angular displacement d theta, which when multiplied by angular displacement d theta, which when multiplied by angular displacement d theta gives work done in rotational motion. Work done in rotational motion. So torque is a physical quantity which when multiplied by the angular displacement d theta gives work in rotational motion. While force is a physical quantity which when multiplied by linear displacement gives work in linear motion. Gives work in linear motion.
Which when
Sir.
multiplied by?
Which when multiplied by linear displacement dr, gives work done in linear motion. This is a physical meaning of torque. That's the meaning of torque. This is a physical meaning of torque. That means torque in rotation motion is analogous to force in linear motion. This is a physical meaning of the torque. Hence, torque in rotational motion is analogous. Torque in rotational motion is analogous to force in linear motion.
Sir, hence torque.
Torque in rotational motion is analogous to force in linear motion.
So what means analogous?
Similar. Now torque in polar coordinate system. 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 Mark it, draw the diagram, okay? Torque in polar coordinate system. Polar coordinate system. The previous was in Cartesian coordinate system. This is polar coordinate system. Draw this diagram. This is position vector r. This makes an angle theta, same like before. But here are, angles we are considering mainly. This is the direction of the force acting. Now we can extend it down. This is the line of action of force. That should be a dotted line, okay? This is the point M. Point M makes an angle theta. N. This is O. This is phi. This is also phi.
Exactly, that is M, right? Beside theta.
This is not theta, this is alpha, okay? This you give alpha. Force makes an angle alpha. See that same color of force I'm using here. This is alpha. You see the force, if you extend it, that makes an angle alpha with x-axis. So position vector makes an angle theta with x-axis. Force makes an angle alpha with x-axis. Now this is phi from triangle OP. This point is P. OPN. It's a right angle triangle, right? Opposite
Yes, sir.
side will be R sine phi. This will be R sine phi. Here we have to prove torque is equal to force into perpendicular distance. That means ON into F. That's what we are going to prove. Force into perpendicular distance between line of action of force.
Excuse me, sir. Sir, what did you write on the line ON?
On the line,
ON.
R
R
sin
sine phi. This is phi. Opposite side of phi is R sine phi. Sine phi is equal to ON by R from the diagram. Sine phi is equal to ON by R, isn't it? Opposite side by hypotenuse.
So
Yes,
we
sir.
should rejoin, right?
Rejoin, it's only one
Sir.
period, right?
1 minute and 35 seconds.
That period we cannot rejoin, right? Because you have next class.
So next
You have
class
another period,
after
right?
9.
So what all lines are dotted in the diagram?
All these light colors. See, P to N dotted line, O to N dotted line. Position vector is there, F is there. These all light colors. See, I'm putting dots there. I think it's time. So next week we'll have a revision, okay?
So which chapter?
From work power energy onwards we'll start. Laws of motion at least once you have written the exam, right? No.
Yes, sir.
Last exam you had a laws of motion?
No, sir.
No, sir. No, sir. No, sir.
Then first we'll finish work power energy from together with physics. I'll dictate some question, we will answer. Then
Okay,
we'll go
sir.
to laws of motion. The next week full revision.
sir.
Then I'll continue
Okay,
with the
sir.
course.
Okay, sir.
Okay, sir.
Okay, sir.
Why not do it
Work
last
power
week?
energy and come. Okay.
Okay, sir.
Okay, sir.
Sir, Hari Arkam, roll number 7. He's